All right. In theory, we're live. Actually, we were live this whole time, right? And you just like
Yeah,
flick a switch
exactly.
and boom. Yeah. All
I
right.
just changed the scene. You're good.
That's awesome. Because do you find that you like wait for YouTube and you're like, okay, we're live. Come on, YouTube, receive the stream. Come on, to go to space or something. Yeah.
This is why I learned from SpaceX to go ahead and just put things live and waiting ahead of time.
Right. Yeah. Yep. Awesome. All right. So what's going on? What's happening? I have no weather to complain about. I feel like this show is going to be empty now because our weather's been fine and mild and sort of lightly rainy and very West Coast Canada normal, as opposed to just the weird firestorms and heat waves and blizzards that we've been having. So.
I got to say, Fraser, the weather here is a little exciting. I mean, we had clouds.
Wow.
I haven't seen those in a while.
Why? Because it was sunny?
It's usually sunny, but you know, it's cloudy. I don't know what's going on. It's very odd.
Yeah, I usually just think the clouds are on fire if I see that.
Yeah.
No, but Fraser, it's below zero in both temperature regimes where I am. So,
oh, good.
And we just had snow.
Yeah, no, that's not right. Yeah, and Dr. Proctor, you're in fairly nice weather, right?
Oh yeah, yeah. I'm normally in Phoenix, but I'm in the British Virgin Islands right now.
Yeah, that sounds all right.
I didn't know you were usually next door. I'm also in Phoenix.
We're in Phoenix.
On the northeast end.
Oh, like Scottsdale area.
Yep. I usually not to admit that.
It's okay, Nick. I have family in Phoenix too. So.
I used to live in
Scottsdale's
Tucson.
boring. Phoenix is fun.
Yeah.
Yeah, I think Arizona or New Mexico are definitely on our snowbird wish list as Canadians. My wife is American, and so she keeps pitching that we should do a winter in New Mexico or Arizona, and
I think that's a fantastic idea.
I think so too. Yeah,
Tucson is like a mecca for astronomy. Like every mountaintop around Tucson has an observatory on it.
And they've got their light pollution under control in Tucson, don't they?
Yeah, they're trying to. I mean, it's still reaching out from the city, but they're making an effort at least. Flagstaff is a cool astronomy town too.
Oh, is that the one there's one that they they figured out the idea of pointing the lights at the ground.
I think it's Flagstaff. Yeah, it was the first.
Yeah.
Hey, speaking of Tucson and astronomy, did you know that the Planetary Science Institute turns 50 years old today?
No.
Oh no.
I got the press release. Yeah.
Yep.
Wow. Yeah, we're pretty well allied with the Planetary Science Institute at this point. I think half of our guests seem to come from the Planetary Science Institute.
Plus a couple hosts here and there.
Plus a couple of hosts. Yeah, exactly. Plus perhaps someone who's engineering behind the scenes. Plus, yeah. I can see now that they have a heavy influence in everything that we do. All right, enough filling time. Let's get on because I am really excited to talk to today's guest. All right. Hello and welcome to the Weekly Space Hangout for Wednesday, February 2nd, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Mars, and Mars, because Nick's here. Dark voids and solar flares, Earth's second Trojan asteroid. SpaceX is going to be hitting the moon with a booster rocket, and a cool mission that's going to be flying on SLS Artemis 1. Joining me this week, we've got, to my right, Carolyn Collins-Peterson. Carolyn.
Hey, how's it going?
Good. We've got Dave Dickinson. Hey, Dave.
Hey, here in Norfolk, all telescopes idled because of perpetual clouds.
Right. So just deploy them all behind you just to remind you of what you could be
I
seeing.
like having them lined up so I can be like, which one will I pick out tonight? I think I'll use whatever,
It's like a pair of shoes or a coat.
Pick it off the row. Yeah.
Yeah, that sounds good. And we've got Dr. Nick Castle. Hey, Nick.
Hey, how's it going?
Good. We had like one whole week that we didn't see you, and now you're back. Maybe
I
it's 2
know,
weeks.
it was totally weird.
Good. Well, you're the hardest working man in planetary news. All right. Before we get on with our special guest, I just want to remind everybody that we couldn't do this show without our good friends at the Weekly Space Hangout crew. They're our friends, our fans, our executive producers. They call the shots. We do what they say. If you want that kind of executive ultimate power, join the Weekly Space Hangout crew. Go to wshcrew.space and they will hook you up. All right. Joining us this week, we've got a very special guest, Dr. Sian Proctor. Welcome, Dr. Proctor, to the Weekly Space Hangout.
Hi, everyone. It's a real pleasure to be here.
The question I always ask people, but I feel like we already know the answer. Who are you? What do you do?
Well, I'm Dr. Sian Proctor. I'm a geoscientist, space artist, explorer, and recently I became an astronaut with SpaceX Inspiration mission, the first all-civilian mission to orbit.
Yeah. All right. Well, oh man, I really want to talk about that mission, but I also want to talk about your background and some of the stuff you're working on. All right, let's talk about the mission. How did you get this opportunity?
Well, I was really fortunate that I've been on Twitter for a while, and I saw that a friend had posted a video about the Inspiration4 Prosperity seat, and I thought, wow, you can win a seat through Twitter. And sure enough, if you created a Shift4 shop to show your entrepreneurial spirit and put together a 2-minute and 20-second Twitter video, you had a chance of being selected for the prosperity seat. And about 200 people applied, and I was the one that won it.
Incredible. How was the training?
The training was awesome and sometimes intense. A lot of book work that I had to do, because even though I won the seat, you still had to qualify for the seat, because I was given the mission pilot seat. And so I had a lot to learn, and a lot to learn with me and my commander about how to fly a Dragon spacecraft. And so it was a lot of studying, going to SpaceX's headquarters and all of that stuff. But then there were things like crew cohesion bonding, which was hiking Mount Rainier. And as a geoscientist, I've hiked a lot, but I am not a mountaineer person. So that was a fun challenge. And then fighter jet flying and centrifuge and hyperbaric chambers. And so just all kinds of things, the things that astronauts would go through to train for a mission.
You launched on a Crew Dragon capsule. How was that experience? I've had a chance to talk to astronauts, and they compare Crew Dragon versus the space shuttle versus being on a Soyuz. You had never launched on a rocket before. What was that like?
It wasn't as bad as I thought it was going to be. People have said that it's like riding down a bumpy road, in like a truck. But for me, the main thing was I was watching the monitors to make sure that the flight computer was doing what it was supposed to be doing. And I didn't notice any shaking or vibration. So I was really able to concentrate on my task. And so that's one of the things where I would just say, it was one heck of a fun ride, and didn't feel anything that was that caused me any concern. That's for sure.
That does sound vastly different when you talk to on the space shuttle. It's kind of fun, very shaky, very, it takes a while to make its way off the ground. And so I've heard that the Dragon kind of leaps off the pad, and it's a much smoother experience. You hit weightlessness. How was that experience, being weightlessness for the first time?
It was incredible. I'd done a 0G flight where you get that, 20 seconds. But this is one of those things where, your MVAC in and stops, and you immediately realize that your arms kind of float up, and you're like, hey, this is new, and they just kind of hang there. And so you're just, it's hard to put into words, but it was more like Peter Pan, because a lot of people are like, do you feel like you're free falling like in a roller coaster or something like that? I'm like, no, it's more like you just are lifted up into the air and it's suspended and you stay there, and then depending on how much energy you put into moving, you can just go wherever you want and be in any orientation you want to be in, which was cool.
That's really interesting, because that's my assumption as well, is that, and even the Vomit Comet, I haven't flown in it, but that you take that experience of like jumping off a height, and the way you feel as you're falling, or when you're on an elevator and it goes down very quickly and you feel your stomach go up, that it would just be that, but it never ends. You're just falling and falling and falling, but it's not it doesn't feel like that.
No, because what happens is instead you just are suspended. It's like, it would be this, if you thought of yourself as being lighter than air, what would that feel like? And so you just hover there, you hang. And then once you add in, a little bit of energy, you just move from one end of the spacecraft to the other. And that's one of the surprising things, is it doesn't take a lot of energy to move yourself when you're just suspended there.
And so the Crew Dragon is actually a fairly large vehicle internal size-wise. It's actually bigger than the Apollo capsule.
Yeah.
How was it living in a Crew Dragon for a few days?
Well, once you are floating there, you've got the ability to have people above, middle, below. So it becomes a lot more spacious when you don't have gravity pulling on you. So to me, it wasn't that bad. I think we all felt, that whole idea of being comfortable, being uncomfortable is how my commander would say it, and I thought it was just like camping, actually a little bit more luxurious than some of the camping I've done in the past.
Yeah. I'm sure that kind of prepares you, but like sleeping, going to the bathroom, eating,
Everything.
Everything. Yeah. You're all sort of trapped in a small space with each other.
Yes, but you have a privacy curtain for when you need to use the restroom. And again, because you can be at different orientations, you can put a curtain up above, and then people can be up over that, doing what they need to do if they're changing or anything, and then everybody else can be down below.
Yeah. So one of the most kind of profound impacts on people is this idea of the overview effect, that when you go to space, you look down on planet Earth and you have feelings. How did that hit you?
It's one of those things where when we first opened up our cupola, our that forward hatch that separated us from our window, which we call the cupola, which is a domed window, and it was the largest window that has been flown to space so far. It was overwhelming how bright our Earth is. As a geoscientist, I knew that Earth had a reflectivity, but I was just like, whoa, this is amazing. And being back, I thought a lot about why we have the overview effect, and you can't get it from just watching a TV show or seeing a book of the Earth. And I'm convinced that it has to do with Earth light. Think about when you have a full moon and you go outside, and how much the moonlight has captivated us. There are stories about it. There are love songs written about it. There are even, werewolves and mischief that happens when the full moon is out, because you're bathed in moonlight. Not only do you see the moon, but you feel the reflectivity of it hitting you. Well, when you're in space, man, the Earth is 1,000 times brighter. And so when we open up the cupola, you were just flooded with Earth light. And it was this pulsating, beautiful, living thing, just beaming with energy. And I think that that's a big component that we don't often talk about is Earth light.
That's really fascinating. Now, obviously, you're a geologist, and when I talk to astronauts, they often have some other hobby. Well, they often have all the hobbies, but for you as a geologist, things probably took more of a deeper meaning. So, how did you look at the Earth with that geologist eye?
Oh, I kept wanting to see land masses and big features like mountain ranges and things like that. But then again, big respect for the oceans and clouds everywhere. Except for when we were over Australia, we joked whenever we saw land, we were over Australia. But right. Definitely, it gives you that global perspective that we are living in a water world, and the systems are all connected, and the clouds, the ability to kind of swirl and move energy from one location to the other, very impressive.
And as an astronomer, what was it like looking at the stars at night?
Oh, one of the things that we regretted is that we were pointed down. So if the Earth was here, we were inverted and our cupola was facing towards the Earth. Right. So for us, the orientation seemed like we were looking up at the Earth, above us like this. But because we had the cupola and how high we were, you could slide up and you could see the entire circumference of the Earth and then the blackness of space around it and the star field. And particularly when we were in the, in the dark side or the night side of Earth. And I just remember two things. One, looking off to the side and seeing our tiny little moon next to the big giant Earth and being like, oh my goodness, there's the moon. And then the second thing was finding Orion and having Orion off to the side and being like, oh my goodness, wait, is that Orion? Yeah, I think that's Orion. And my brain trying to work it out. But being able to see the stars was pretty fantastic.
Yeah, it's like, from what I've heard, it's so dark that it's actually really tough to find your constellations because all the stars look so bright. And
that's the thing where I think because we were still facing the Earth, so the Earth was taking up most of our view, but it was the dark side because we were night. But you have artificial lights and stuff like that, and so it wasn't as bright as it would have been had we turned and faced into the deep space field.
Now you with your geology background, with your there you go. That's right. That was the mock-ups they released before.
Right? Yep, that's what it looked like. But that gives you a sense of how high up you could slide into it.
Yeah. Oh, I'm amazed you guys didn't just fight nonstop over who got to have their head poking out of that thing. But like you've done lots of projects. You've been on like high seas, right? You've done Mars simulations. You've done. So have you considered taking this sort of going with this experience and going back and applying for your astronaut wings, like to become an astronaut?
Well, we are astronauts.
No, you've got your wings. I mean, as a career, as a job, joining the astronaut corps.
Yeah. No, that was one of the things is NASA will never say that they have age limits, but all of the data shows that, women tend to skew young. If you're past 9, your chances of being selected are 0 to none. In the history of NASA, there's only been one female selected over 40, and that was Barbara Morgan. And if you know the history, Barbara Morgan was actually the backup for Krista McAuliffe. And so as a teacher in space, and so she got to be selected for the astronaut corps and officially became the first teacher in space. So that's the only one exception, and it was a unique one. And so now, I'm in my 50s, and so I know that my chances of being selected with NASA are, well, there's no history of it. It's not saying that they won't eventually get there, but they just haven't done that. And so I would love to go up again, but I would bet if I do, it'll be commercial space and not through a federal agency.
Based on your experience, do you feel like that opportunity is now going to be more available to people, regular
Yes.
people, to be able to fly to space?
Yeah, look at last year. I mean, well, and when you say fly to space, you got to count in suborbitals, right? I mean, how many people flew last year that were civilians? I mean, we had William Shatner. Captain Kirk went to space, and Wally Funk, and and Michael Strahan, and just it's just amazing that not just me and my crew, but the commercial space flight and opportunities for people just like you and me who have always dreamt of going up there. There are unique opportunities that are allowing us to do that, and that's exciting.
Yeah. And I think, as we see more competition, more of these fully reusable rockets, prices coming down, like it's still going to be expensive, but it kind of like a trip to Antarctica expensive as opposed to $50 million expensive.
Right,
So,
right. But also, hopefully there'll be more that follow the model that my commander Jared took, where, you're not only solving for space, but solving for Earth, but you're also making a choice to, open up access to those who would normally not be able to select it or be able to afford this kind of experience. And that's the whole point behind and if Inspiration4 is to inspire, and you want to set that bar pretty high because we're writing the narrative of human spaceflight now, and we want it to be a Jedi space, a just, equitable, diverse, and inclusive space for all of humanity, and so that means we have to actively make choices to strive for that. And really push back when you see private companies or groups that billionaires who are flying space, and their whole motto is just to make money and be for profit and not be thoughtful in what they're trying to do.
Yeah, I mean, do you think that there's a way to kind of balance those ideas? Like, obviously, these companies, their businesses, it costs money to build rockets and launch rockets and maintain them, but at the same time, there is a lot of value that can still be done, a lot of science that can be done, a lot of education outreach. Is there a model moving forward that can make it a more equitable experience for people?
Sure. I mean, if you're gonna have billionaires pay for it, have them pay a little bit more and give one of the seats away. There's 4 seats. Take 3 billionaires and one you give away. Or you do a campaign like we did, where we've raised over $250 million for St. Jude Children's Research Hospital. Have that model of solving for space solves for Earth, and that you're going to actually figure out how to give back to our planet, and in some meaningful way that is significant, and not just smoke and mirrors.
Yeah. I mean, you can definitely feel a certain amount of discontent, especially on Twitter and stuff. People see billionaires flying to space, and I think you're exactly right. The opportunity to raise money to raise awareness, to raise money for causes that matter, to give people a chance to take these flights and to inspire, do outreach, to be key to their plans, and to not is a mistake. And I think you guys are a living example of that working out really well.
Yeah, well, Jared Eisenberg was very thoughtful in how he structured this mission, and he says could have just taken some buddies along, but instead he literally took 3 strangers with him to space. And then on top of that, he said, why don't we raise $200 million to try to end childhood cancer as we do this?
Which would pay for many flights to space. So,
but
it's great.
Yeah, because you think of again, as we push out to Moon, Mars, and beyond, but there's no place better than Earth, and everything that we do for the advancement of human spaceflight, we should be doing twice as much to make sure that life on Earth, all life on Earth continues to thrive, not just survive, but thrive.
Yeah. Now, you've written a book about your experience, right?
I have. It's called Space to Inspire, The Art of Inspiration, and it's based on me becoming an artist and a poet. So I became an artist and a poet during COVID, and then when the opportunity came for Inspiration4 to show my entrepreneurial spirit, I could have, applied as a geologist or an analog astronaut or any of those things, but I said, no, you should send an artist and a poet. And then I did an original poem called My Space to Inspire in my video, and people loved it, and that's how I got selected.
That's fantastic. I mean, exactly right. The fact your scientific background and your analog astronaut experience both would have easily qualified you for this mission, but it's great to extend it and bring your entrepreneurial spirit to the table as well. Dr. Proctor, if people want to find out more about what you're doing, learn more about the book, what's the best place for them to follow what you're working on?
They can buy the book on Amazon. You can just search for Sian Proctor, and they will try to respell it a different way. So you have to say, no, I really want Sian, S-I-A-N Proctor, and then you'll see the book. And the book is fully augmented, has augmented reality of me reading the poems. Wow. So it's interactive. And then I'm at Dr. Sian Proctor on social media like Twitter and Instagram. So I'm mostly active on Twitter and Instagram, so people can follow me there.
Perfect. Well, it was an absolute pleasure to talk to you. Congratulations. You are definitely an inspiration to the rest of us who would love a chance to fly to space. And it was quite exciting to hear your point of view.
Thank you for having me. And I hope you all get to go up one day.
We'll let you know. All right. Take care. Thanks. I'll never go to space.
Never say never.
Never say never.
They got to be taking some journalists at some point.
Yeah. Are you kidding? At some point. All right. Let's move on to this week's news. Carolyn, I choose you.
Great.
Let's talk about dark voids and solar flares.
Right. Well, all right. Because it's below zero here, well below zero, I'm going to talk about the sun.
Nice. I remember that.
Yeah. It's been really cold. It's like minus 20 Celsius, I think, here right now, or maybe a little bit colder than that. And we had a little snow, and I haven't seen the sun, although it did peek out a little bit today. Aim at the sun at some point, but I haven't had a chance to do that. So anyway, yesterday there was a story released about some mysterious structures called SADs, that's short for super arcade downflows, and I'll explain them in a second, that occur when we have solar flares. Now, for people who are in the audience who may not know about solar flares, I'll give you a teeny little background. These are outbursts that release a lot of energy over very short time periods on the sun. And that means by short, maybe seconds to tens of minutes long. And they radiate across the electromagnetic spectrum. And they are particularly bright in X-rays. Some of the best really cool images of them are in X-ray wavelengths like this one. And the flare in this image is down in the lower right limb. And the flares actually stretch up from this photosphere of the sun and the chromosphere up through the solar corona, and they're involved in heating the corona and sending out massive wads of electrified particles. I said they heat up the corona, so they'll heat it up to millions of kelvins right in the area of the flare, and then you see these huge releases of electrons and protons that move out, some of them at the speed of light. And if that happens to hit the Earth, then we have interaction with our magnetic field. Now, these flares actually happen in active regions on the sun, so they're mostly around sunspots. And we see these very intense magnetic field structures emanating out of sunspots. They look like magnetic loops. You can see that here. And you see in this one, you see an awful lot of them bunched together in what's called an arcade. Now, the loops emanate out from the sunspot region up through the photosphere, well up into the corona, and they carry these streams of charged particles and plasma along the magnetic field line. So just think of these as a loop of a magnetic field. Now, during solar flares, well, the magnetic field, these loops all get bunched together. They get twisted, they can get stretched, and it's kind of like you take a rubber band and you stretch it around. And if you do it long enough and you do it energetically enough, you can snap the rubber band. And that same thing happens with these magnetic field lines, and that's called magnetic disconnection. And at that point, when it snaps, it releases all this energy, all this radiation that we see, and that's the solar flare. Then magnetic fields very quickly reconnect, and the whole process starts all over again. And that is, one thing that the way they talk about heating in the upper atmosphere of the sun. Now, during solar flares, you get these odd structures that appear that are called supra-arcade downflows, and they call them SADs for short. And I've got an image of them here that was just released yesterday. They're part of the arcades. And so you can see where the arrows are pointing, where these kind of darkish areas are. Now, these were actually not a new discovery. They were first detected in 1999. But people really couldn't figure out what they were. They were very puzzling. They looked very mysterious looking. And so people got to work, solar physicists got to work to figure out what they are and what they have to do with solar flares, because they seem to be exclusive to solar flares. At first they thought maybe they were somehow connected to the magnetic reconnection and disconnection and reconnection. But these dark areas move very slowly. During the disconnection, most of the area of plasma and stuff moves back down pretty quickly, but these dark areas did not. So that kind of intrigued a group of solar physicists from Harvard CFA, and they started looking around for high frequency time-based images of solar flares. And they came across the images that are made by the Solar Dynamics Observatory, and there's an instrument on there called the Atmospheric Imaging Assembly, and it takes images of the solar atmosphere and these flares once every 12 seconds, or just about that time. So there's a ton of data that they could use, and they use it also to make a 3D model of a flare in the event of these fingers kind of moving slowly back toward the surface of the sun. So it turns out, after a great deal of study, and to jump to the end here, that these SADs are actually voids in the solar plasma. They're not cooler regions. They're not, something else weird. They're not aliens. They're just these voids that are in the solar plasma. So there's no plasma in these whatsoever. So then they had to figure out, well, why do you have these sort of tubes that have no plasma in them? And they figured out that the reason that they exist is that there are regions of turbulent plasma that are kicked up during the flare. And these regions have different densities, the plasma does. And after the flare and during the flare, they actually try to mix, and they can't mix. It's kind of like mixing oil and water. They just don't mix. So instead they separate, and it leaves behind this void that then slowly settles down towards the surface of the sun. So that's kind of what these SADs are. And I think people had noticed these. They couldn't quite understand what they were, but now they think they have an explanation for them.
I have no questions. Yeah, that was.
Well, I did actually.
That was a beautiful. That was like a, you just perfectly
solar physics in 2 minutes.
Yeah,
right?
You explained the whole thing of solar physics. Went up to the new. Everyone should just take notes. That was picture perfect, Carolyn.
Thank you. Well, I will say the question: why are we studying these things if they don't last very long and they're these tubes? I mean, what's going on? But what people are trying to do is figure out sort of a second-by-second analysis of what solar flares are and what they do. So here's this gap, these gaps, these voids that are kind of slowly settling down. Do they cool the area? Do they have what are they doing here? And that's the kind of the next step. So they're going to be studying these more. And of course, the ultimate goal here is to understand, can we start to predict these things? Can we start to understand what's happening? Because of course, here on Earth, if we get hit with a massive highly charged electrons and neutron protons, that kind of plays hell with our space weather.
There's
so
no
we want to understand what drives them.
There's no word if Parker or the European Space Agency's solar orbiter are going to get any kind of a better look at these, or?
Yeah, I didn't see anything about that. I need to go and. This just came out yesterday, so I started looking around. Solar Dynamics had the biggest amount of data, it looked like, but it seems to me like they had to be focusing on that. Yeah.
I wonder how much of this was Earth-based as well, like with the Daniel K. Inouye telescope.
Well, the discovery was, but this, but the most of the data that they used to make the model out of was from Solar Dynamics, which is sort of a workhorse,
We were at AAS. Did you get a chance to see Daniel K. Inouye when you were like 2 years ago, or?
I didn't get to go. That was right when the pandemic was starting, and I really didn't feel comfortable traveling. So
I've seen the data.
I would love to. Yeah. Yeah.
They had a really cool video of the transit of Mercury, I think 2019, like
Yeah.
a really high-res video of the transit of Mercury.
Well, and I've actually been to Haleakala. I just haven't gone the rest of the way up the road to see it. And it was still under construction when I was there, but I would definitely love to go there.
Yeah. Awesome. All right. Dave.
Yes.
Which one do you want to talk about?
Let's talk about the SpaceX booster first, because that's kind of the weirder story. This came out, was Bill Gray at the Project Pluto mission actually discovered this very curious, he put it out there on a minor planet list. That's of Discover back in 2015, that this mission was the one that we see that stares back at the full disk of the Earth from the L1 Sun-Earth point, and launched in 2015. Gives us those really cool full disk views of the Earth, and sometimes you see the moon transit in front. This mission also left a discarded S2 Stage 2 booster out there that they discovered is going to hit the moon on March 4th, strangely enough. Now, we've hit the moon with a lot of things before, but this is the first time we're going to hit the moon with something that wasn't meant to go to the moon, that was just out there in a long looping Earth orbit or solar orbit that we've seen. I mean, we put a lot of space junk out there that's gone into heliocentric orbit that's probably hit the moon before, but we've never actually observed this happening or predicted it's going to happen. So
as you said, we've done this before. L-Cross, there's other missions that impacted.
They were meant to hit. And the very I think the very first thing that ever went to the moon in 1959 was Luna 2 hit the moon. That was a Soviet mission. That was the only thing they could do at the time is just to manage to send something and hit the moon. So
that sounds like the way I play Kerbal Space Program.
Yeah, first you hit an object, then you orbit it, then or you fly by, then you orbit, then you land. So
or you hit it and you hit it again and you hit it again, and then you.
And that's what NASA did when they went to the moon with the early Pioneer missions. They hit the moon. The Rangers, they hit the moon many times before they actually managed to soft land.
It still happens, like the Indian mission, the Israeli mission. The moon is as hungry for spacecraft as Mars is, I think.
India's recent lander that crash landed, Israel's the Beresheet lander that crash landed a few years ago. And this one, all the Saturn V boosters, or the upper stages, those hit the moon eventually when they orbited the moon as well. Unfortunately, this is hitting the far side, so we won't see it. It's going to be hitting because it's going out past the moon, back around, and it's going to hit near its Hertzsprung crater on the edge of the far side.
Chinese should see it. They've got I don't know if it has any cameras on it, but they've got a relay satellite on the far side of the moon.
I don't think it has any cameras. The best we might see is the Lunar Reconnaissance Orbiter in Chandrayaan, India's Chandrayaan-2, are currently in orbit and active and have imagers that they may see the resulting crater. So we may see some imaging come off this. It's actually twice as big as L-Cross because it's about not quite 4 metric tons, this Stage 2 booster. So that
was my question, was like, do we know how much damage this is going to do to the moon compared to the attempts on purpose?
Yeah, well, it's twice the mass of L-Cross, so probably at least twice to 4 times the impact size. What would really be cool, what I think is ironic, is SpaceX is actually launching missions to the moon for, I believe it's Intuitive Machines, this summer. There's a bunch of commercial lunar payload services missions that are going, part of NASA's contract program. There's Astrobotics and there's Intuitive Machines. But SpaceX is going to reach the moon just a few months prior with this impact. It's going to be the very first time they've reached the moon, albeit not the way they really anticipated on doing it. So
it's funny. Some people on Twitter were a little mad that SpaceX, that Elon Musk is desecrating the moon with
we've hit it a lot of times before. It's not a new thing.
and it's like, it was for a NASA mission.
Yes.
That is being used for Earth observation and helping with climate change and weather and things like that. And would you rather have it hit the moon or have it enter the Earth's atmosphere and pollute the atmosphere with debris?
Well, there's talk about all these Starlinks. I follow re-entries, and we have a Starlink coming in nearly every day from the older constellation is already re-entering. So nearly every day a Starlink satellite is coming in. So that's already occurring. So
I mean, there's, I forget the name number, 1,000 tons of space debris of rocks is entering the atmosphere every year.
I only wish this could be impacting the night side on the near side of the moon, like at first quarter phase or so we could actually, that would be optimal for actually viewing it.
It would be visible in a telescope, no problem.
Yeah, if it hit on the night side.
Yeah.
Hey, Dave.
Yeah.
Do the Chinese have a seismograph that they might be able to capture?
That's a good question. They might on Chang'e 4 or 5 that are still active down there.
Or the lander. I'll bet you they do.
I know during the Apollo missions, the ALSEP landers that the astronauts left there that were nuclear powered, they had seismographs, and some of the booster impacts they did pick up before. So there's a possibility we might observe it that way.
Very cool. All right. Well, we'll watch and see what happens. I'm sure we'll get that first picture from LRO a couple of days after, when it actually surveys the site. Nick, let's talk about Perseverance choking on a rock.
Yeah. So this story started off a couple months ago when Perseverance went to ingest one of its latest samples, and a couple of the rocks fell out. Actually, the other picture would be a great one to show, and got caught in the coupling. That's what makes the interface between the drill on the arm and the sample handling unit inside of the rover. So the question rapidly became, well, what do we do? These rocks are sitting here in the coupling device. We can't just sweep them out. I mean, that's what we do on Earth, is we take a brush and we brush it out. But we don't have that kind of brush on Mars. So for the last about a month and a half, they've actually been working on troubleshooting how exactly we're going to remove these rocks. So what they came up with was they drove the rover up to one of the maximum safe tilts, which is about 13 degrees on that side, and then did several things to try to vibrate the rover. It turns out the rocks actually probably fell out during the drive to get there, but the point is they fell out. So we're good.
Good.
All of this is to say that drilling on Mars and collecting samples is actually really, really hard. And this is something you wouldn't really think about until you start to look at the list of, we built these drills, we built these devices. They should work fine, right? We tested the crap out of them, in the Mars yard at JPL, in other engineering environments. Tried to put them in realistic environments for Mars, made sure everything would work. Get to Mars, and how did that rock get there? Yeah. Earlier on in the mission, the very first sample they tried to pick up actually crumbled. It fell apart. There was no solid piece to stick in the handling mechanism because it was all just little crumbled bits. So, how do you deal with all these things when they come up? Because it's not like you can just send a technician there with a brush to clean out the interface and try all over again. So it's actually pretty cool to watch a lot of this. And I love watching how creative the JPL engineers are at trying to do what intuitively you'd want to do, but it's just hard. Because, if you can't brush it, you kind of want to take the rover, turn it on side, and shake it.
Yeah.
And they did that.
That's so great. I mean, we've seen like what would be fairly simple things for a human being to deal with are enormously complex operations for a robot. A good example of what's happening with the lander, with the what's the name of it? The one with
Are you talking about
probe.
InSight, the geophysics lander?
Yeah. So with InSight, with its mole, and it wasn't able to deploy this mole, and they tried everything. Tried to hold down the mole with the shovel. Yep. They tried to dig a little hole, tried to push it in, and so yet
for context,
obviously
this was the thermal probe. They want to look at the temperature profile of the first. I actually forget if it was a meter or
it was going to be 10 meters. It was 10 feet, 3 meters.
Okay. Yeah. So it was trying to burrow into the soil, and it's in a pretty loose soil area, so it shouldn't be too hard to kind of squeeze your way in. And they built this system that could do it without having to dig and drill, because if you're drilling, you've got to remove all those tailings and get rid of them, which they couldn't really do well. And you're going beyond, like the Curiosity rover has a drill that drills about that deep into the ground. It's brilliant. It's awesome. It's great. Perseverance, we go a little further. It's about that big. Think of a large piece of chalk. That's kind of what you're aiming for. But now we're talking, this was more than a meter. You can't just drill that. It was actually supposed to squeegee its way down into the ground. Well, it didn't work. It started, it barely got a start, and then it got stuck. Well, what do? Well, if you're on the ground, you pull it back up and you try again.
Yeah.
Except,
or you're an astronaut and you walk over with a great big temperature probe with a hammer and you go bang, 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 bang. Oh, there's a rock. Pull it back up.
And that definitely happened.
Bang, bang, bang. Yeah. Right. So,
I forget which of the Apollo missions it was where they tried to bang it into the ground. Same kind of device. Still looking at the thermal profile of the soil. They're looking at how much heat is coming out. And for everything they tried, the astronauts could not get it to go more than about a foot into the ground.
Wow.
Everything they tried just hit a rock.
I think it was Apollo 15. I'd have to look it up, but I'm not certain.
I'd have to look it up too. I'm not quite the Apollo expert.
I'm thinking it was.
I love me some Mars, though.
Yeah. And so, I mean, it's just this kind of stuff is fairly normal. They're unexpected, but it's like the unexpected is normal. And you got to be ready for it. And whenever it comes up, you have to.
And that's one of the beautifully brilliant things about how this stuff is engineered. Like on the Curiosity rover, the one that I deal with day in and day out, it's got 4 different motors on its arm. Each of those motors is not just, an engine that takes a gear. It's a whole set of gears. It's a set of brakes. It's built in such a way that if it fails in a safe position instead of just, breaking and falling apart. And then there's backups to all of these pieces. It's amazing how much engineering went into, okay, this is how it should work. This is how it should fail. And here's how we recover when it fails in the way we didn't think of.
Yeah.
It's so cool.
Yeah. I think my favorite stories are these stories of recovery and snatching victory from the jaws of defeat. Even the Kepler loss of reaction wheels was a nightmare, but the fact they were able to come up with a clever idea to use one reaction wheel and the light pressure from the sun,
the K2 mission was cool,
to keep it pointed and get more data is just amazing. And those kinds of stories, I just find them so inspiring. It's like
I absolutely love it.
Yeah, these disasters are inevitable.
I'm sorry, you made what work? And how?
And how? You did what? Yeah, exactly. It's sort of like the Apollo 13 where someone goes and
I love that scene.
Yeah.
We got to make this. Fit in the hole made for this, using nothing but that. I love it.
Yeah, exactly. Right on. Thanks, Dick. All right. Carolyn, do you want to talk about the Earth's second Trojan?
Sure. Yeah. So just today, actually, there was a story released about Earth's second Trojan asteroid. So Trojan asteroids are basically in the same orbit as Earth around the sun. And other planets have them: Jupiter, Venus, Mars, Saturn, they all have them or have had them. So yesterday, a team of astronomers in Spain released a story about that there was a second Earth asteroid confirmed. Now, this was first found in 2020. And they had to study it and confirm it actually existed. And so it is now, it's called 2020 XL5, and it orbits out at a Lagrange point somewhere near L4. We're not real close to it. And it looks like it's going to be in that orbit for about 4,000 years. And so since it's in that orbit, it's not really going to cross our orbit. It's not posing any threat to Earth. Well, I thought that was kind of the whole story. And then today, as I'm writing the story about this, another paper comes out that claims that this Earth Trojan was probably inserted into orbit or nudged into that orbit in about the 1500s. So its earlier orbit brought it close to Venus, they think, and gravitational nudges probably pushed it into the orbit it's in now. So it's sort of, long story short, it's not dynamically stable over the age of the solar system, but it's moving around. So this little guy is about 1 kilometer in diameter. That's larger than the first Earth Trojan. The first one was called 2010 TK7. And it's about 1/3 the size of this new one. And we're interested in this because, there's 2 things. We're interested because, they give us a lot of information about asteroids about conditions in the solar system in the area where they formed, and in particular where Earth formed, since their compositions might be kind of close to what the compositions were, the planetesimals that formed Earth. they're close to the planet. They're relatively in the same orbit as Earth. And so they could make good targets for future space missions, which is sort of the second thing that they're important for.
Yeah, I mean, I like the idea. I mean, with the Lucy mission, they're going to fly out, pass through Jupiter's Trojan belt, fall back in, fly out to the other one, fall back in, which is great because there's a whole bunch of interesting objects all clustered together. But you can imagine a flight out to, say, Earth's L4 or L5 Trojan region, and it could hang out there and then study many objects that are all caught up in that gravity well with the spacecraft.
Yeah, these probably aren't the only two. I mean, these guys are hard to find. I mean, they're basically at these L4, L5 points probably, and so if you want to go to observe them, they actually in the sky, from our point of view, show up kind of close to the sun, which means you got some horizon challenges. You're looking through the thickest part of the atmosphere. You don't want to burn out your detectors because you're too close to the sun. But these guys actually did take some pretty big telescopes and look for them. They used the 4.3 meter Lowell Discovery Telescope and the CTIO 4.1 SOAR telescope in Chile to find this. So they're on the right track. They're finding them. But to your point, this actually is a pretty easy place to get to energy-wise.
Yeah,
you don't have to spend a lot of high energy to get out like you have to do to Jupiter or to Mars or whatever. You can get out there pretty easily. And if you want to send something out there, you can send miners if you want to. You can send something that's going to go out there and take samples. And actually, one of the things that they put in the story was gives you a good example of when to go and study that we might be able to put some kind of installation on to do long-term studies of these things.
But as you said, it's not going to be with us forever.
No, in about 4,000 years, it's so it's actually in kind of a not a perfect orbit. It's about, I think it's inclined about 14 degrees to the orbit of the Earth, and it's not in a dynamically stable orbit. So it a few nudges of Earth's gravity or whatever will knock it out.
Yeah.
It's only about 4,000 years, so we don't really have anything to worry about right now.
We've got to hurry.
Yeah, get those spacecraft out there.
Yeah, absolutely.
So it's kind of a cool. So they'll look for more of them. They're probably out there, but they're small and they're dark and
very cool.
They're hard to spot. Yeah.
Dave, let's talk about a solar sail mission.
Yeah, this actually does tie in with going to a near-Earth asteroid potentially in the next few years. There are a bunch of small-sat missions that are launching with the Space Launch System's Artemis 1 launch now in April. Of course, we talked about this right before the show. This just dropped earlier today. That they bumped it back again, SLS. It's not unexpected. I skimmed the press release reading it today that they want more time to complete the integration with the Orion capsule and the VAB before they do rollout in March. So read rollout in March, then the launch window where they want to go. There's a 2-week launch window in the middle of April, then another one in May. So that's when SLS is going. But it has these 10 little CubeSat missions. The first Artemis 1 launch is going to be uncrewed, and this is just to test out. This is a full-up SLS, largest rocket ever. This is going to be the one that's going to return people to the moon in the next few years. And this has been, it's had cost delays, budget overruns. It's the same story as James Webb. It's been pushed back and back and back. But now it may finally launch this year on its first Apollo 8 style return trajectory around the moon, test everything for the reentry. But when it's going around the moon, it's going to release these 10 small CubeSat payloads, and one of them is NEA Scout, which is Near Earth Asteroid Scout. And this is a really ambitious mission. I hope they pull this off. This is Marshall Space Flight Center and JPL that worked on this. It's in a 6U CubeSat, which is breadbox size. It's not big. When it gets out there, it's going to unfurl this big solar sail, and it's going to use that to kind of spiral out of the Earth-Moon system to go toward the asteroid is 2020 G. It was only discovered a few years ago. Has a low enough delta V that they can approach. Comes near Earth every few years, or near being within 500,000 miles or so, twice the distance to the moon. It's about 5 to 15 meters across, so it'll be the smallest thing we've ever visited. It'd be smaller than Itokawa, than Hayabusa, or the one that Hayabusa visited, and Ryugu and Bennu will be smaller than all these little 1 kilometer size asteroids. But it's going to have a camera on board. I'm kind of curious about the solar sail unfurling, because when you watch the video when they're doing it in the lab, the guys actually having to tug on the ends and get on both sides. And they're looking, it's like, there's not going to be a guy in space to tug on the end of the sail. So I hope it can unfurl okay on its own when it's out there. But it's supposed to encounter the asteroid in the late 2024 timeframe. Yeah. And this will be a good proof of concept. Like I said, if we ever want to go to the Trojans or go to any of these kind of small 6U CubeSat missions, if they can pull it off, we might be able to get a closer look. Incidentally, this asteroid 2020 GE is about the size of what blew up over Chelyabinsk a few years ago. So, if we see one coming our way, it might be interesting to know what they're made of. And we're going to be seeing something like the Chelyabinsk asteroid up close in a pristine space environment. So it's going to be an interesting mission to see.
Yeah. I mean, just more solar sails, please.
Yeah. Solar sailing has had a rough time to get into prime time. The very first one, when I was researching the article, Cosmos 1 was launched on a Soviet submarine-launched missile, and the missile failed. That was with the Planetary Society. They tried again with their Light Sail 1, and Light Sail 2 did better in 2019. Yeah. The Japanese had some luck. Yes. The Japanese had some luck with Ikaros that was on the Akatsuki mission to Venus. That actually worked for a time. There was the nanosail. We used to track nanosail in orbit. You could see it. That was used more to show that you could use this kind of solar sail technology for controlled reentry. The idea that these could be built standard on satellites, so at the end of their mission, they could re-enter rather than staying in orbit. So,
yeah, really cool. All right, we've got about 2 minutes left. Nick, is there life on Mars?
We don't know.
Okay. Thanks everyone for. All right, I'll give you a longer. Yeah, but this was a debunking of the Allen Hills meteorite.
Sort of. So the Allen Hills 84001 meteorite, this was recovered from Antarctica in the 1984 field mission, Antarctic Meteorite Survey. This has been one of the most controversial meteorites for a number of reasons. And one is, it's the oldest Martian meteorite we have. It's about 4.1 billion years old. We used to have an estimate of about 4.5 that got revised. It's old. It's a different composition from every other meteorite we have. It's an orthoperoxenite. And if you're not a geologist, that means nothing to you. It's different from what we normally talk about when we talk about Martian meteorites. And then in 96, David McKay published a paper that said, and we have definitive proof on of life from Mars. And he showed pictures like this one that we're highlighting on the screen. And that object right in the center, that kind of wormy looking thing, it turns out it's made out of magnetite. And it sort of looks like what would happen if a bunch of magnetic bacteria with an organelle called a magnetosome were living in this meteorite and got captured by it. Well, it turns out with years of study, there have been several lines of evidence that were presented to say this is life on Mars. Through the years since then, we've proven basically every single one of them, or at least the consensus is, yeah, it's more likely that that wasn't a biologic process. Like these bits of magnetic minerals that are on there were actually probably formed by shock waves. So this meteorite, being about 4.1 billion years old, is from during the late heavy bombardment on Mars. So this is when Mars had a crust, and that crust was getting the pulp beaten out of it by rocks falling from the sky. So there's shock waves going every which way, and that can actually form things like these grains of magnetite, and it'll form them in these little, what we call lenticular features, this wormy-like shape. But it sure looks like biology. And so there's been this interesting back and forth over it for years that got really bitter between some of the scientists. Well, we've taken some time and we've let that simmer down, and now we're looking back at it to say, do we see evidence of organic molecules? Now, to be clear, what I mean by an organic molecule is not a molecule that was made by life. It's a whole class of chemistry. It's things that contain hydrogen, carbon, oxygen, among other things. And it turns out this does contain some organic molecules that definitely formed on Mars, not on the Earth. Many meteorites that we recover have bits of organic molecules on them from things that happened on the Earth, but these happened on Mars. And so they've been looking at how did these things form? One of the possibilities, of course, is life, but the one that's strongly supported by this recent study that was published, the lead author is out of the Carnegie Institute in Washington, They're looking at the relation of these organic molecules to serpentinites. So serpentine is a mineral that forms by weathering of stuff that happens from volcanoes, basaltic rocks, specifically olivine, but also pyroxene. And it turns out a lot of these organic molecules seem to have formed on top of these serpentines. And so this looks like just a geologic process. But because these molecules contain carbon as well as nitrogen, it tells us that we had an atmosphere that had carbon dioxide to get into the surface water, because water is necessary for this reaction, and nitrogen, and significant amounts of it to be able to incorporate that not just into the water, but into these chemical reactions happening in the subsurface water.
So did this meteorite just do Perseverance's job?
This meteorite is backing up some of what Perseverance is trying to do, and Curiosity for that matter.
Yeah, it found the chemicals that were required for life, not necessarily life, but at least showing that the conditions were more amenable to life than we previously thought.
Absolutely. And this is one of the big things that motivated Perseverance as a sample return mission, is trying to get the right samples to really study this in detail in places where we think it's likely. To be clear, this kind of rock is an unlikely place to find this sort of stuff. But it did have a little bit of it, and so we're doing some of that study. And it's amazing how much you can do in a lab that's just really hard to do with a remote mission.
And that comes back to the downsides of having a robot trying to do a beautiful, amazing robot trying to do field geology doesn't hold a candle to a lab here on Earth with those samples in the hands of scientists.
I absolutely love my rover, the Curiosity rover, but in the 10 years plus that it's been operating, it's done maybe a month and a half of field work.
Yeah. All right. Well, we've reached the end of our show. Carolyn, if people want, what are you working on and where can people find out more?
Well, if Pam could bring up this picture that I have, my last picture, I'm working on trying to get my telescope out there to do some more observing, but it's very snowy, so I'm not doing that. So currently I'm planning my observations, and there it is right there on our deck. Right. So, and on top of that, I'm working on a book about planets, so that should be keeping me busy for a while. If you want to learn more about me and my work, I'm at Space Writer on Twitter, and you can come to thespacewriter.com.
Perfect. Dave.
I also have an EV scope over my shoulder here among the row of scopes. I frequent contributor to Universe Today, Sky and Telescope, Bionis Telescopes, and Astro Gear Today, and author of Universe Today's Ultimate Guide to Viewing the Cosmos, and from a few years back, our Deep Sky Field Guide. And I'm hatching an idea in my brain about doing something on amateur satellite tracking. That's cool. I'm either going to start or I'm pitching it around. To my knowledge, there are a lot of astronomy guides out there in the market, but I've never seen one that's devoted solely to satellite
I don't know of one.
But
it's a great time for it. So
more and more, more like the articles I was talking about tonight, more and more, that's what I'm talking about is what SpaceX is doing. So
yeah, that's really cool. Yeah. All right. And Nick.
I'm getting my wandering scientist concept going. So far, I've actually taken my little infant to 3 national parks. That only leaves 60 more to go.
That's great.
I figure I've got 18 years.
Yeah. Well, and don't forget, we've got a bunch in Canada, too. So
yeah.
When you run out of
we're
those,
definitely going to try to visit those when Alberta's numbers are not crazy.
Yeah. Good luck. Yeah, we're like a couple of weeks behind the U.S., and so we're seeing our crazy numbers now. But hopefully we'll come down the other side of this slope as well. We've got much higher vaccination rates, so I think it should settle down pretty quickly. So, all right. And of course, I'm Universe Today and all the things. I did a great interview with Dr. Jillian Scudder today on my YouTube channel. A lot of fun. Great conversation. I think you'll really enjoy it. So come check that out. All right. Well, thank you, everyone, for joining us today. Thank you to all of my co-hosts. Thanks to our special guest. What a guest. That was so great. Thank you to everyone watching on YouTube and on Twitch. Thanks to all the moderators. Special thanks to Nancy Graziano and Dr. Pamela Gay for engineering behind the scenes. We really couldn't do this without all of the people involved. Thank you, everyone, and we'll see you next week.